Hi everyone, and you are welcome to this lecture, Python sets. In this lecture, we are going to learn about another collection in Python, which is set. So I will start by defining what a set is. Then we will see how we can create a set. We will learn about set operators, how we can update a set, and we will see some useful set functions. And as usual, I'm going to end this lecture by a quick summary. So let's get started. Let's start by defining what a set is. Set is a collection of distinct items. It's useful when we want to deal with unique items regardless of items' frequency. From this definition, we can understand that no one items can be repeated inside a set. And you have to know that set mainly cares about items' availability or existence, not about items' frequency. Now, when you want to add an item to a set, you have to make sure that item is a number or any other mutable data structure like string or a tuple. So I cannot put a list, for example, as an item inside a set because list is mutable data structure. Now let's see the set details. As you see here, in order to create a set, we use a curly braces. Set is not ordered data structure, which means there is no meaning for the order of items inside a set. Set is mutable data structure because I can add or remove items after I create the set. Set is not indexed, and you cannot use indexes whether they are positive or negative to get access to the set items. And also set does not support slicing, so you cannot extract a subset from a set using slicing operator. Now let's move to PyCharm IDE to see some real examples about sets. The first example that I want to show you is how we can create a set. So I will create a variable, its name ProLanguages equal to, and I will put curly braces, and then I will put the item C, for example, comma, C#, comma, Python, and so on. So you will note that I use curly braces to create a set, and I use comma to separate between the items. And here there is no key value like the case of dictionary. So be careful because we also use curly braces to create a dictionary. Now let's check the type together. So if I say print type, programming languages, and let me print also ProLanguages and then run. As you see, the type is set, and these the items of the set that I already created, which is ProLanguages. Now let's talk about operators that can be used with a set. Before I show you examples, I want to show you some diagrams that will help you to understand how these operators work. Let me assume that I have the following two sets, A equal to 5, 25, 145, and B equal to 11, 25, 5, and 8. The first operator that I want to talk about is intersection. Intersection is an operator that helps me to find the common items between two sets. In this case, we note that between the set A and set B, we have 5 and 25 common items. So if you want to find these two items, you have to use intersection operators. And in this case, you can use either intersection as a function, or you can use AND as an operator. Now, if you want to know what are the items that are available in one set but are not available in another set, you have to use difference in this case. So you will note that, for example, 1 and 45 are available in A, but they are not available in B. So if you want to find these two items, you have to use difference operator. And this can be achieved by using difference function. So you have to say A dot difference B, or by using minus. And in context of set, minus will calculate the difference. Now, if you want to know what are all the unique items that are available both in A and B, you have to use union in this case. And here if I say A dot union B, I will get this big set which has all the items that are available both in A and B. If you want to calculate union, you have to use union function. So you have to say A dot union B, or you have to use union operator, which is this bar in this case. Now again, let me assume that I have the set A, which is equal to 1, 2, 3, 4, B equal to 1, 2. Sometimes I need to understand the relationship between two sets. I mean by relationship here, is one set is available inside another set, yes or no? So to answer this question, you have to use is superset operator and is subset operator. Is superset and is subset can be represented by larger than or equal, smaller than or equal. So in this simple example, you will note that all the items which are available in B are available in A. So here we say A is bigger than B, or A is superset of B, which means all items of B are available in A. Or we can say B is a subset of A, or B is smaller or equal to A, which means all the items that are available in B are available in A. Now let's move to PyCharm again to see some real examples about these operators. First of all, let me assume that I have the following three sets: data types 1 equal to numbers, string, lists, sets, dictionaries, data types 2, which is numbers, strings, dictionaries, sets, and data types 3, which is sets and tuples. Because I explained all of these operators in the presentation, I will not explain these operators again, just I will show you the example. So, if you want to calculate union, you are in front of two options. You can use union as a function. So in this case, you will say data types 1 dot union data types 2, or you can say data types 1 or data types 2. If I run, you will note in these cases, I get exactly the same result, which is all the elements between the two sets. Sometimes you want to calculate the union between more than two sets. In this case, you can pass as many as you want of sets inside union function, or you can use OR operator as many as you want to calculate the union. Let me run now. And as you see here, I get exactly the same result between the operator and the function. Now let's see intersection. In order to calculate intersection between two sets, you have to use intersection function or AND operator. Intersection will help me to find the common items. So let me run now this code. And as you see, I get strings, dictionary numbers, sets, which are the common items between these two sets. And again, I get exactly the same result between the function and operator. So they are equivalent. You can use anyone you want. Like the case of union, if you want to find intersection between more than two sets, you can pass as many as you want from these sets inside intersection function, or you can use AND operator as many as you want. So if I run now, as you see, I will get sets. Why sets? Because sets is the only value that's common between the three sets that I have. And that's about intersection. Now let's move to the difference. And difference, it's operator that help me to find the items that are available in the first set, which are not available in the second set. So here I'm asking, give me the difference between data types 1 and data types 2 using difference function or using minus operator. And if I run and show you the result, you will see I will get lists. Why lists? If you note here, lists is available here, but it's not available here in this set. So I get the difference as sets. The second example here is to show you that you can use difference also to find the difference between set and other sets. And here you can pass as many as you want of these sets, or you can use minus operator as many as you want. So if I print now, you will get lists. Why lists? Because lists is available here, but it's not available here or here. So the difference in this case is sets. Now let's see examples about is subset and is superset. It's very straightforward. In case of is subset, I'm testing whether the set on the left, it's a subset of the set on the right. You can use is subset function or smaller or equal operator. So if I run now, I will get in both cases true. Why true? Let's check. We're asking data types 2 dot is subset data types 1, which means all the items inside data types 2 should be available inside data types 1. And as you see here, all of these items are available here. So I got true in this case. And it doesn't matter what you want to use. You can use is subset function or smaller or equal operator. Is superset, it's a function that will test if the items of the set on the right are available in the items of the set in the left. So in this case, if I ask is data types 1 a superset of data types 2, which means all items of data types 2 should be available in data types 1, and we already see that, so I will get true in this case. And here let me run to see the result. Look, in both cases it's true, and it doesn't matter if you use the function or the operator in this case. The last operators that I want to talk about is membership operators, and as you see here we have in and not in. In is operator I use usually in order to know if one item is available inside the set. So here I'm asking, is numbers available inside data types 1? Yes, it's available, so I will get true in this case. If I run, I get true. Not in is the opposite of in, which means I'm asking, is this item not available inside data type 1? And also I got true here. Why true? Because float is not available in data type, and this is a question that I am asking. Is not available, and yes, it's not available, so I get true in this case. And that's all about the operators. Now let's talk about some functions that usually could be used with set. First of all, let me assume that I have the following sets, which are the same of previous examples about operators. Now, usually we can update the set content in two ways, by adding an item or removing an item. So, if you want to add an item, you have to use the function add. How we can use it? It's very straightforward. First of all, I will print data types 3, then I will say data types 3.add lists, then I will print after the addition. If I run, As you see, this is the set before using add, and this is after using add. And as you see here, this is the new element. The opposite of this function is remove, and remove, it's a function that remove an element from a set. So I will print data types before removing and after I remove sets from this set. So you will note here that in the original set we have sets tuples. After removing I have tuples only. If you want to know the set length or how many items a set has, you have to use len function, and it's very straightforward function that take set as input and return value which is integer, and it represents the number of items. So if I run here len for set 1, which has 3, 2, 12, 34, 7, as you see I will get 5, which is number of items. Other functions that are straightforward, we have min function, which find the minimum value of numbers inside the set, and in this case I have 2. So if I run, I get 2. But if you want to calculate the maximum, you have to use the opposite function, which is max. Max take one argument, which is set 1, and if you run, you will find the maximum value, which is 34 in this case. And the last function that I want to talk about is sum function, and sum, it's a function that help you to find the sum of all numbers inside the set. And as you see here, it take an iterable. Set is considered as an iterable, and it returns a value which is integer in this case or float according to the sum. So let me run. And as you see here, the sum is 58. And that's all for this code session. Now let's recap what we have learned in this lecture. First of all, set has been defined as a collection of distinct items, and we see that it's impossible to find one item repeated more than one time inside the set. The set item should be a number or any immutable data structure. In order to create a set, we have to use curly braces, and set is not ordered, is immutable, is not indexed, and set does not support slicing. Now please, I want you to refer to Python set appendix, in which you will find all the available functions and operators have been summarized. Also, please refer to Python sets challenges in order to find some exercises to practice what you have learned in this lecture. Thank you very much for your time, and if you are available, join me in the next lecture.